Swayam Prabha. Digital India. Educated India.
Okay, my name is Ravindra Getu. I'm from the Department of Civil Engineering in Construction Materials. So I'm going to talk to you about some issues related with materials, especially special concretes, and then maybe we'll have a discussion on what can be used, what cannot be used, what can go wrong in terms of precast. Okay, so there are a lot of materials. See, a lot of materials are there, but we'll talk basically about concrete. But it could be any materials. A lot of materials are used today which are precast. All of us know that window frames, what are the materials that we use as window frames now? CPVC, aluminum. Before we used to use MS, yeah, that was very, very common. Okay, so we can think of many things like this. Roofing systems, partitions. Partitions, again, lot of elements you can have. Can have drywall systems which can actually come in a module and you can put. So there are a lot of possibilities of what can be prefabricated. Now we are also talking about sandwiches, where a wall can have different layers. Inside you can have insulation, which is a polymer. Outside, inside you can have you can have mortar, you can have concrete. So a lot of things are possible, but generally we'll talk about concrete most of the time. But I want to sort of look at sustainability also. All of us have heard of sustainability, right? All of us like this word sustainability. Anyone thinks we should not be talking about it? Everyone likes it? Okay, what is this sustainability thing? So basically, we have to bring in sustainability in three aspects. Generally, what is sustainability? Can someone give me a nice definition? I'll give you my definition, but give me a definition, since everybody likes sustainability and probably you've been told that prefabrication is good for sustainability. Yeah, what is sustainability? It should be long lasting. Not always, no, but I think it should be long lasting. Environment negatively, okay. Should be eco-friendly, also same thing, no? And eco-friendly and environment. Anything else? Reduction in carbon footprint. Use of minimum resources. Raw material consumption should be okay, good. Should be cost effective, okay. It should be easy to recycle, okay. What else do you think should be in sustainability? Anybody else? Any architects here? No. No architects. One architect. So architect's point of view, anybody who is architect? Yeah, Vidya. So both of you should tell architect's point of view, what do you think is sustainable? Minimum energy consumption in the fabrication, in the operation. The operation energy should be low. Good. Climate responsive means what? That it should adapt to climate change. Is that it, or? Okay. So it should be, so if it's sustainable, it should be for in the climate context, it should also be sustainable. Yeah, very good. Anything? Lease maintenance. So it should be easy to maintain. Cost of maintenance should be less. Good. Aesthetics should be good. Yeah. You don't want something ugly, right? Good. Very good. Yeah. So I simplify it and say that sustainability is something that is good for all. It should be good for everyone. Yeah, which is very easy to say, but it's very, very difficult, because all what you have said may be good for some and not good for somebody else or something else. Well, someone mentioned it should last for a long time. Suppose you build a house, how many years do you think it should last? 50 years? Anybody else? 50 years is good enough? Depend on the structure. So if it's a hostel, how long should it last? 100 years. If it's a bridge, how long should it last? 100 years. Okay. So why don't we build everything for 300 years? Cost will be first. Usage, obviously, no? Usage is a problem. Cost will be very high. Then somebody said aesthetics. Why don't we make buildings which will always look nice? Maybe cost, something else. So it's always, so that's why I said sustainability, ideally, in my definition, it should be good for everyone. But it's very difficult. It's very difficult. You always have compromises, trade-offs. And I always have fights with architects. For an architect, suppose you live in a mud house with a thatch roof, that is good. Yeah, Justin, you agree or not? Energy consumption, in terms of cost, in terms of sustainability, very eco-friendly. But how many of us would want to live in? Yeah, how many? I will not. Anybody would like to? Yeah, that's the most sustainable, right? You go there, you dig the earth, take mud out, you build the walls, go around, get some tree branches, and you have a roof. So this is how people used to live. A lot of people still do like that, right? But that's not, that's in most of your definitions except durability, it will be sustainable. It could also be aesthetic, it could also look nice, but it won't. So sustainability is something that we have to define project wise. Like Vidya correctly said, it's climate specific, it's also application specific, it's user specific. And when we say cost, somebody said cost effective. I have one slide, I didn't bring it here, where I have the Ambani house, and in front of that there are these small sheds of people living. That is affordable for the Ambani, this is affordable for the people living there. So affordability also is very contextual. So whatever it is, whatever you define as sustainability, we have to look at it in 3 stages of a project. First is design. Okay, you cannot design with materials or systems that are not sustainable and expect the structure or the application to be sustainable. So we have to start with design. So we have to understand materials, structural people have to understand materials, construction people have to understand materials and technologies and so on. So design is the first step of thinking whether you want to be sustainable or not. Next is construction. Construction also can be unsustainable if you use a lot of energy. A lot of people said energy. Suppose you do have a lot of wastage. You have a lot of wastage in material, in time. It's not sustainable, right? Even if it's very eco-friendly, the materials you're going to use, but you take a lot of time constructing it, or there is a lot of wastage, lot of raw material used unnecessarily, then it's not sustainable. So construction also has to be done well. Someone said maintenance should be less. Lot of our maintenance problems come because of bad construction. Okay, so construction is very, very important. The third aspect is quantification of everything. Do we just say something is sustainable, like I told you? Like if I go with a mud house and a thatch roof, it's sustainable, but no, if nobody wants to live there, is it sustainable? If nobody can use it for more than a year or 2 years, it's not sustainable. Okay, so we have to learn to quantify. First, we have to understand what is sustainable. We have to think about metrics, measurements, rules for calculation. This is very, very important. Okay, so whatever you do, same thing applies to prefabrication. We cannot jump in at some point and say this is good or this is bad. Okay, we have to first start with design. We have to design efficiently, we have to construct efficiently, and we have to quantify whether something is good or not. And we have problems of all types. We have experience on our campus and other on prefabrication. We think it's sustainable, but we've had problems in all these aspects. Generally, what we say are the advantages and why it is more sustainable. You can construct faster. Okay, there will be lower dependence on labor. Now, we might say that dependence on labor is good because it is cheaper, it gives livelihood and so on, but it also induces lot of errors that could happen. You have to depend on the skills or unskilled laborers. So this also has some consequences. Your factors of safety increase, your tolerances increase, your overheads increase. quality is always an issue, like you people said about sustainability. Quality, the defects matter. And if you do not look at it, we won't get this 50 years, we don't get 100 years. There are buildings which are collapsing in few years, right? So we have to look at better quality, and this is something that is very difficult, because how do you know if something is of good quality or not? Especially in concrete, it's very, very difficult. We feel quality will be better because it is in a factory that you make the precast elements, prefabrication. So it's becoming more of a factory product rather than inside, at the site. But mostly you will find that still something has to be at the site, done at the site. So from all the lectures you've seen, what are things that you have to do at site anyway, even if the element is prefabricated? Joints, foundation. So you cannot avoid it. So what is the use of having a fantastic prefabricated element when the joint is badly done? Okay, so their quality again matters. Sometimes we think prefabrication, all problems are solved, but there also it's important. Durability. Again, if the joint fails, if you have corrosion in the joints, then what is the use of talking about durability? Okay, cost, obviously, then the impacts and maintainability that you also mentioned. So these are advantages, but they could be also limitation if you don't do it. So lot of in buildings, that is part of this the main scope of this course. Lot of options are there. This is from 2017, one of the big buildings by a major contractor called Shapurji Palonji. So they have used, this is a project where 1900 units, precast walls, panels, slabs, staircases, beams, 67,000 precast elements. Okay, so one thing we start noticing when we look at these success stories are the project has to be big. The project has to have a lot of space. Okay, so this, especially in a country like India and probably many other countries, will become the factor that is going to tell us if it's going to be successful or not. You have to have a large project. Similar, these are projects for lower middle income groups by Sidco in Mumbai. And again, lot of elements. Here you can see some pods also, right in the middle. You see that there are some pods. Yeah. So these are not only 1 or 2 dimensional, but now you have 3 dimensional elements. These are toilet pods, or these could be smaller elements. Then you have walls which are very long. This, I think, is about 15 meters or something like that. And finally, if it's done, it looks like no different from any other building. The interiors also are very nice. Here, you cannot see it very well, but all this is prefabricated. There is even a window sill of granite, and then you have this element, which nicely integrates the window and so on. So you can have elements that can be prefabricated, picked up, and put in place. Okay. You might have noticed in some hotels, if you stayed in one of these large hotels like Ibis, or I don't know if Ginger also, the toilet is completely prefabricated. I don't know if you've noticed. It will usually be polymer, it will look plastic. If you hit it, it sounds plastic. And everything is integrated. When it comes into the building, the sanitary ware is all fitted. Okay. You have your WC there, your sink there, lamps, everything is put in there. They just fix it, and then you need 3 connections out. You need water, sewage, and electricity. Okay, so that is the power of prefabrication. But you have to have a lot of volume. So this is very, very important. So what I think, from what I've discussed today, what we can do in India, there are certain things that we have to focus on. It is not the structural design. Structural design can be done. It's like what we design always for. First of all, if you want to do precast, I think it has to be a large project. So talking to people, it looks like it has to be at least 4 million square feet. So that means it's a 1,000 crore project. Okay. You cannot decide my house should be prefabricated and start it. It won't work. We have burnt our fingers trying to do one small lab. Yeah, it will take a lot of time. It's not going to happen. Why? Why do we need such a large project? Number of repetitions will bring down cost. Otherwise, it's huge investment. Okay, good. What else? Yeah, reuse of molds. How many times do you think we can reuse a metal mold? Has somebody talked to you about it, or you should know? It will be only about 70 to 100 max. Steel molds, only about 70 to 100 max if you're doing this. So we think it will be a lot. At least this is what they told me at the site. Yeah, I don't know who told you 1500 times. Don't believe all these handbooks. They are written by people who don't know anything. Yeah, they are recording this. I don't know if I should say all this. Yeah, yeah. Go to site. Talk to people from the site. Talk to people from the site. So metal molds will not last for long time, because then they get dented, they'll get eroded, then leakages will occur. Generally, even if you use tunnel formwork, what is called Maiwan formwork, 70 maximum 100 is what you can use. After that, it becomes very difficult to have the finish and the corners and all that stuff. You can do it. You can do it. As opposed to, say, if you want to use plywood, how many times do you get a repetition out of plywood? 4 to 5, maximum 8. This is the thing. So these are things we should remember. Now, what else why else do we need a large project? One is repetitive, reusing. What else? Labor gets specialized. Very good. Labor gets specialized. It is not like doing it for the first time. They will make a lot of mistakes. If you have 4 million square feet, you can throw away the first 10. But if you're doing a house, you cannot. You're only going to make 10. No, you cannot throw it away. All right. So you can make mistakes, you can learn, and you can become better. The engineering cost is very high, right? Engineering cost is very high. You have to design elements that can be lifted, placed, jointed, and all these things. So again, costs become better, easier to manage. Your overall cost comes down. Per square foot cost comes down when you have a larger project. Okay, margins are better, so costs come down. Otherwise, generally prefabrication is more expensive. Did anybody tell you what would be generally if you do a smaller project? What do you think will be the overhead? Yeah, what will be the additional cost? Suppose I am doing in situ versus precast. I do a project, say, 1,000-room hotel. How much do you think will be the additional cost if I go prefabricate? Minimum 25%. Okay, so it depends on the specialized thing. So cost also will go up. It will not come down all the time. It comes down only when the scale is huge. Okay, if you're trying to do something small, cost will go up. So for this reason, at least in India, right now, we can do prefabrication of buildings only in a very large scale. The other thing is you need a lot of space. You cannot have a small site in the middle of the city and say, I want to do prefabrication. It generally will not work. So you need about 10 acres for a factory. Okay, so obviously if you're talking about, say, even a plot of 10,000 square feet or 1,000 meters, it's not going to work. Even though you are very gung-ho about it, you say, I took this Gyan course, I want to make my houses precast, and everywhere I go it should be only precast. Not going to work. Yeah? It's like bursting your bubble, but it's not going to work. Nobody will listen to you. It's not going to be cost effective. Logistics will be a nightmare. Okay. We have to go for automation. So again, this pushes up your cost. You need robots. Lot of these are not made in India. Like the project I showed you of Sitco, all these batteries of molds are coming from Italy. Okay, so this means that you have to import Automation obviously decreases your dependence on labor, but it is also cost, it is engineering that we may not have today. Okay. So people who talk about, say, factories, they are doing some elements repetitive, and that's all that you can get. So if people are doing hollow core slabs, it is of a certain type and you have to adapt your design to that. You cannot say that I want something different, then it's a whole different game. Okay. Safety. I don't think anybody talks much about safety in prefabrication. You imagine that you're building something like this. Okay, something like this. And here you are building at the top and all your elements are all pieces. You have to have 5 guys there who are handling pieces of several tons and joining them all together. If you are doing it, will you feel comfortable? If you are not comfortable, will you care about quality of construction? No. You want to do your job and get out of that as fast as possible, right? So this is a very interesting angle that we are looking at with Professor Nikhil Bogalia. How does your perception of safety affect the quality of construction? Imagine up there with all the winds, everything is swaying. A crane is bringing down a wall or a column or a beam. Yeah, we have trouble in a ground plus 1. Imagine you're doing 50 stories, 60 stories, and everything is moving. But you're saying, make sure joints are good because this will dictate your durability. That guy says, I want to finish and go home today. Right? So this is also very interesting that we don't think a lot about is how do we look at safety, putting these large, huge elements together at very high levels that has risks, and because of the risk, the perception of the worker changes and the worker is not going to focus on quality. So one of the things that a lot of companies do, not in these sites that I showed you, but some of the sites is they put like a barricade or a net outside. So when the worker is at the top, they don't see the vacant space or they don't see that they can fall. So it's like a net that is put around, it creates some safety and then things become better. So safety is something that we have to look at. Safety is something we have to look at. There have been accidents. There have been cases where people can get hurt because you have these huge tons of elements, weighing tons moving around, and you're talking about wind and heights. So safety is important. Joints, like everybody must have talked to you about joints. So joints are important. We have to prevent leakages. We have to make them aesthetic, robust, and so on. So joints are very, very difficult to do, especially if it's a vertical joint. A horizontal joint, at least you can inject and do something, but vertical joint becomes very, very difficult. Once you put something in, it's very, very difficult to make sure that is waterproof. So now what people are doing, at least for horizontal joint, is they are doing ponding in every room. Okay, what is ponding? Where have you seen ponding usually done? You do slabs curing, right? Curing, you do pavement, we do ponding. Suppose you're doing a toilet, you do ponding. Now, what in big precast projects they're doing is the users themselves are saying we will pond every room. So the builder now is doing the ponding before they give it, because after they give and they find out it's a leakage, is a big problem. You have to remove the tiles and everything. No, so joints are very, very important. Joints have been the reason of failure, structural failure, and many other things we have to think of. Now, the last thing could be the solution for not restricting prefabrication to large projects. Suppose I have a catalog of products which are all designed for a certain load and a span, and I can just buy off the shelf. Like I go to Amazon and say I want a beam of 5 meters that I can use for house application, and they deliver. Or I say I need a wall. So off the catalog, you design for these things. We already do it now. Like your AAC blocks are all of a standard size. Your brick is of a standard size. We adapt it to our design. So can we do the same thing for prefabricated elements? Instead of you saying, I want this dimension and this shape, I open a catalog and say, already some company is giving you this. I order 100 of these, and then it works. So industrial construction in the Western world happens like this. You have big companies who have catalogs. So you will open and you will say that this is what I get, and you do the design later for that. Now, can we do buildings like that and all that is a question. Yeah, but we'll have to think of it. This is the only way to avoid what I said in the first two bullets. Otherwise, it has to be large projects with a lot of space. Otherwise, you will not be able to construct. Okay. So the only way to avoid restricting prefabrication to large projects, high volume, high cost projects is standardization. What sometimes people call cookie cutter approach. Lot of people will not like it because it takes away your freedom of design, right? We put architects out of business because you will not have that flexibility to design. All your beams have to be similar size, your slabs, your columns, all will become similar. But I think it's still, there will be possibility of expression and things can be done. Okay. Okay, so far, any questions, disagreements, protests, complaints? No? Are you awake? Sachin, are you awake? Yeah? Questions? Vidya, you had a question? No, don't want to ask. Okay, no questions? I go on? Okay. Now, this is one concept that we've been trying out. We thought this would be a interesting thing, but we faced a lot of problems. I don't know if somebody talked to you about this already. Who? You visited. Okay, you visited, and then I'll tell you what the base is for this. See, the idea was that you want something to last, like somebody said, hostel should last 100 years. Seems to be a good approach. But do I need to be sure that that building will last and be used as the hostel for 100 years? I don't know. Like if you look at our oldest building, which is our oldest building on campus, those from campus should know. BSB, right? BSB or next to it. Building Sciences Block is our oldest building. It was used as the rectorate or the directorate. It was used as the library. It was used as all our offices. I don't know if it had labs or not. Yeah. But now you have all sorts of things in BSB. So if I build a hostel or an administrative building that is supposed to last 100 years, I don't know whether I'll use it for 100 years. Will I even have so many students in 100 years? Not sure. So the concept came about that can we make the shell of the building to last 100 years, but interior need not be for so long. That sounds obvious, no? Why should my paint last 100 years? Why should my doors last 100 years? So can it be different? All right. So what we said is we'll focus on this idea of repurposing. Somebody initially, when I asked about sustainability, saying reuse. So can we design with that idea? My interior of the room should be repurposed. That sometime, say in 20 years, 30 years, I say that this building, I don't want to use it as a hostel anymore. I want to use it as a lab space. Yeah, I want to use it as a classroom. Can I dismantle the interiors without bothering the structure? Okay. So this is where this concept came, and this is not new. The Japanese do it a lot, and so then this concept of prefabricated, pre-finished volumetric construction came. That you make the room in a factory, come and plug it in. If it's a toilet, it needs 3 connections. What does it mean? Electricity, water, and sewage. If it is your living room, needs only 1 power socket. Yeah. So can we go to that concept where we say that I finish everything almost no construction activity on site. How many of you been project managers or construction managers here? No one? How many of you have been involved in some construction, your own house, you've seen something? Know that some hands are hesitatingly going up. Yeah, you know all the difficulties. No, the carpenter comes late, the painter will mess up the tiling, and then after the electrician will cut your beam also, exactly in the middle, right? So all sorts of things will happen, cracks will come, and then they'll all blame each other. Where are usually the leakages of your house? In the electricity ducts. Yeah, almost always. This is big. So what did we say? We said, can the room be made in a factory, checked and brought in and just placed? Now, obviously, you're wasting money, because now I have two walls, I have multiple walls instead of just the structure. But the idea is that this overall long term helps you, and you can also reuse this material. Now, this gives an opportunity to use materials that may not be as good as concrete. If you agree with me that concrete is good, yeah, I make my living out of concrete, so concrete is the amazing material that I'll talk about. But there are other material like gypsum board, cement boards, could be some polymer board that I can use interior, because I don't need it to last 100 years anymore. So I can use it inside, I can use wood, I can use lots of things. Okay, so this is the idea, that we want to go to institutional buildings which the shell will be designed for long term durability, 100 years. But the interior is empty. We fill up with rooms that can be dismantled without touching my structural wall or my structural system. The structural system is stable without the interiors. So stability is not affected, durability is not affected. I just do this, and when I don't want, I just collapse them, remove them. In Japan, what they do is they actually take the wall, take the room out. We thought that will be too expensive for us to do, because you will have to have a dismantleable wall as well. So we are looking at possibility of just collapsing, just removing some bolts, and you can remove the room. So this is one of the concepts that we'll see how it goes. But these are this is actually a picture from our panel. We'll see how it goes. So these are some ideas that I think are interesting to have when we are talking prefabrication of buildings. What are issues? What are problems that we have with materials? For concrete, we need very early strength. Did anybody talk to you about what is strength requirement of concrete normally in prefabrication? 15 hours, 50 megapascal. 15 megapascal in 15 hours. Okay, so that's difficult. That's difficult without steam curing. Why we don't want to do steam curing? Cost. Yeah, we want everything cheap, but we want it to last 100 years, right? So this is a problem. We don't want to do steam curing, but we want 15 megapascal. So what does that rule out? So what can I not use now, because I need this 15 megapascal in 15 hours? I cannot use fly ash. I cannot use GGBS. I cannot use LC3, which we told you in some other place that that is the most sustainable thing. You cannot do it. So this is again a big problem. Even if you want to pay for it, the builder cannot use it. So this is a big challenge. Okay, so we have to work on it. This is actually an interesting research problem, but this is a real problem. When you go to a builder and say, why can't you use fly ash? Then they tell that I will have to leave the element in the mold for 3 days, 4 days, right? And that brings down the cost, slows down your project. Your factory size has to now become 3 times bigger, 4 times bigger. All this is cost. Okay, so this is what I said. Sustainability has to be for all, for everyone, and it's difficult. It's easy to talk about saying, put fly ash, my concrete is sustainable, my structure is sustainable. Sometimes it cannot be done. Okay, then strength gain. Can I make use of the strength gain or not? Now, Why do I need this 15 megapascal in 15 hours? I have to demold. Then what happens? Then I have to lift. Then I have to transport. Then I have to place. When do I place? Depends on my strength gain. When do I pre-stress? Depends on my strength gain. So this is also a problem. Now, what one interesting thing is happening, and I'm glad Professor Amlan is here because he is the person that inspires me a lot. When you need an M50 concrete for prefabrication, what do you think is the mean strength that they actually use? Less or more? First, less, more, less, more. How many say less? Nobody. How many say more? And how many say I don't care? What, let them use whatever they want. They're about 50% of the class say I don't care. I want to finish today and go home. They usually use more. You'll be surprised that if I specify an M15 prefabrication, normally it's an M75. Okay, so you can imagine a lot of things. What is the problem? Like for the people who said I don't care if it's M75, what is the problem? Is there a problem, or there's no problem if I use M75 instead of M50? Huh? Very good. Brittleness is higher. Excellent. Brittleness is higher. Okay. You say, okay, only these fracture people know about brittleness. Others don't even know. Why do you want to tell? Okay, very good. Brittleness is higher. Then what? Could crack because of brittleness. What else? Cost is unnecessarily higher, no? You're paying unnecessarily higher. That is why I told you your precast is going to be how much more costlier? This is one of the reasons. You are designing with concrete which was not necessary as per structural design. What else? What else could happen? Shrinkage will be higher. Okay. And what is the problem with shrinkage? What is the problem with shrinkage in prefabrication? Joints? Don't give me one word, give me one sentence. Such. No, joints will keep opening. Joints will keep opening. And you imagine you have a structure that you built, you put your things together in 3 days, 7 days, and then over the next few months, by the time you believe all your joints are going to open. This is reality. This is what is happening. Joints keep opening. And when you finish, the joint will crack. If you have a wet joint and you put mortar there, the mortar will crack. This is a big problem. And nobody really cares about it. Why? Your structural designer will say, I have designed it for M50 only as per code. The concrete guy will say, I cannot give you that. That's why I'm doing this M75. This is a big problem. They don't talk to each other. Only Professor Amlan and I talk to each other. But generally, structures people and materials people don't talk to each other, even at the site. They don't, because the structural designer is sitting in the AC office and he has put M50 on the design drawing, no? But this other guy is facing problems from the lifting guy. The lifting guy is saying, I want 15 megapascal in 15 hours. Now, this is another party. This guy says, how can I build? I'm the construction manager. You have to give me 15 megapascal in 15 hours. So the poor concrete guy now designs M75. Otherwise, he cannot give you that M15. Okay. So there are 3 different parties who don't talk to each other in prefabrication, which creates a huge problem. Okay. There is the structural designer who is using the code, no fault of them. They are doing it properly. Okay. They are looking at 28 days strength, 28 days shrinkage, all this. But the guy who is lifting and placing has to do it in 3 days, in 7 days. He is not worried about 28 days. He is sure the thing will not collapse. But he has to put it in 3 days. Right? When you talk to people who are at the site, 15 hours it comes out of the mold. 3 hours it has to be in the site. 3 days it has to be in the site. At 3 days it has to be in the site. And after that, strength is going up, shrinkage is going up, creep is going up. Yeah. So these are the problems that we'll have to understand. Shrinkage and creep are becoming serious problems. Okay. We are seeing joints opening, we are seeing cracks, and this is something that we have to look at. Designing on 28-day values is not right when we are doing prefabrication. We have to design on actual ages on when it is done. The other thing are jointing materials. We generally don't know much about jointing materials. As civil engineers, as structural engineers, we don't know much. We leave it to other people. They do whatever they want, and then there is a problem. There is a problem which will cause leakages and which will cause durability issues. Okay. So these are two things in terms of materials that I would like to highlight. Okay. Questions? Questions? Complaints? Yeah, complaint. Yeah. Structure becomes thinner. Ideally, yes. Will decrease. Yes. If you gain a lot in terms of volume of material, yes, it should decrease. Yeah. But that will only decrease the cost of your concrete. Okay. But the cost of concrete is very small. This change in cost of concrete is very small compared to your whole structure. Yes, when you decrease the volume, it should decrease. The volume you use is decrease. Yeah. But also you must keep in mind that if I'm doing a regular construction on site, what concrete will I use? How many of you are from Tamil Nadu? Yeah. Generally, what concrete we use, say in PWD or regular construction, what is the grade of concrete we use? M25 is high strength. I think M15 still is okay. M15, 20, 25 is good construction. Yeah. But prefabricated, what have everybody told you we should use? 45, 50. So I save there, but I lose somewhere else. Yeah. So precast doesn't mean I'm saving a lot in terms of material, because I need much better quality of material. Yeah. So that is not why we are doing it. Yeah. There are other reasons, mainly speed of construction. Speed of construction, quality, reputation. That's why we're doing it, not to save material. That won't give you much save. Yeah. Any other question, complaint? Yes, ma'am. Yeah. Not directly related. Not directly related. Shrinkage is a very difficult animal. There are actually 5 different types of shrinkage. I don't know if I have a board. I can write here, no? Can I write here? Okay. So shrinkage. So what is the first shrinkage which starts? Plastic shrinkage. Okay. So what is plastic shrinkage? So what is plastic shrinkage? Whoever who said plastic? What is plastic shrinkage? That occurs when concrete is fresh, very early. Okay. So if you're at a site and you see concrete, when you come back from lunch break, it is plastic shrinkage. Yeah. You go and come back 2 hours, 3 hours, there's cracking. It's plastic shrinkage. It'll be crocodile type, crocodile skin type, there's no regular pattern. There'll be all zigzag. That is plastic shrinkage. Okay. And that is because of very high evaporation. How do we prevent it? Normally, early curing. Early curing, cover a slab. Okay. So curing is very, very important. So if you're doing a large slab, those of you who are at the site or structural designers, you should always specify covering the concrete as soon as it's cast. Especially sunny day, June in Chennai, you should cover immediately. Suppose you have a large slab, you cannot wait for the whole slab, then start curing. Okay. So cover, sprinkle, pond. So this is the mantra. Cover, sprinkle, pond. First you must cover. Next, soon as you can move on, sprinkle water, then you should do ponding. Anyway, you're going to do something on top, no? Yeah, anyway you're going to do. You never use a direct thing. Even if you're going to do a polishing, it will not matter. It will not. Okay. So that is plastic shrinkage. Then, related to this, when should I start curing? When do you usually start curing? 24 hours? 24 hours. You took my course, no? Did I tell you that in class? What, lab? Yeah. So this, please forget this. Don't do it at 24 hours. And if you cast on Saturday, when did you cure? Monday. Yeah, please don't do this. The concrete doesn't have a holiday. It will happily crack. When should you start curing? Don't listen to him. I disown him completely. I've never seen him in his life. Okay. When should we start curing? Somebody said something? At setting. At setting. When concrete sets, you must start curing. Not 24 hours. Not 24 hours. Okay. You should start curing as soon as the concrete starts setting. And what I tell people is, you take your thumb, push into the concrete. If your thumb does not go into the concrete, then start curing. Yeah. Don't wait 24 hours. And on the next working day, the concrete doesn't know all these things. The poor thing cracks. Okay. Soon as setting starts, because it'll start drying, especially plastic shrinkage. Okay. What is the next shrinkage which starts? Okay, we'll say autogenous and thermal. Both can start together. Good answers. Autogenous, is the spelling correct? Or is there an E after N? An E? Are you sure? Okay. Autogenous. Autogenous is self-induced drying. So when you have a lot of cement, say you have 450 kg cement, you have 20% silica fume, you have fly ash, the inside of the concrete starts to dry without it losing water to the outside. And also the chemistry, the chemical reactions are such that there is some shrinkage happening in nitration. Okay, so that is autogenous, and this becomes very important when you go to higher grades. We are talking about M50, M60, M80. Autogenous shrinkage is very high. It can be as high as drying shrinkage. The code doesn't even talk about it. Yeah, so this can cause cracking. Then the other thing is thermal. So what is thermal shrinkage? Thermal shrinkage happens because temperature of concrete goes up while setting. All the reactions that cement and water have are exothermic, right? It gives out heat. So you're setting. If you ever touch concrete, if you touch the surface of concrete after few hours or next day, you'll find it's hot. Okay? Because temperature has gone up while setting, and then it has to cool down, because everything cools down to ambient, and when everything cools down, it contracts. So there is shrinkage. That can also cause cracking. All right. So thermal shrinkage cracks, when will they appear? Suppose you're a consultant and somebody calls you and says, there are cracks in my diaphragm wall or slab. First thing you should ask is what? When did you see the crack? Half your money you earn that way. Just with this question, half your consultancy fee you've already earned. If they say, soon as we cast, we just went for lunch and came back, plastic shrinkage. Okay. 1 week time, I demolded, diaphragm wall is all cracks. You ask when? Thermal shrinkage. You will see that it's every 3 meters. You ask them also, appear very intelligent. You say, should be 2 or 3 meters, no? They say, yes. Full consultancy fee paid. You have not even gone to the site. Thermal shrinkage is very regular. It will cause cracks. Diaphragm walls, very typical. Walls, thick elements, you will have cracks occur. Autogenous shrinkage might take longer. Again, you will have periodic cracks. Maybe in 2 months, you will see things like that. Then afterwards is your typical shrinkage, which is drying shrinkage. Drying occurs much later. Then you have carbonation shrinkage. That will be after many years. This occurs after many years. It will be similar to plastic shrinkage. It will be pattern type cracking. No, not very regular. Okay. So these are the different shrinkages. So the question was, why should higher strength concrete be more worrisome? Because you put more cement and it is gaining strength, then there'll be higher autogenous shrinkage, higher thermal shrinkage. So one thing interesting is that these three are important for higher strength concrete. These are important for lower strength concrete. That is why when I was a student, the first three was never taught to me. Because for me, when I studied, M25 was high strength concrete. Yeah. So you can imagine how old I am. Our IS 456 was only this much. Small book it was. So higher strength concrete means you will have higher plastic shrinkage, you will have higher autogenous shrinkage and higher thermal shrinkage. Anything above M45, you will have to be careful about this. You may not need to worry about drying shrinkage and carbonation shrinkage because you made the permeability so low that it doesn't matter. Okay, so this is something you have to remember. Okay, any questions? Yeah. No, you don't do it. You think, if you are the structural designer, you think so. The guy at the site wants to do it at 3 days, not 28 days. What will they do with all your elements sitting in the factory? You will not give them space, no? You want it to be cast, lifted, placed, and up in the site. Because you want to rotate. How fast do you want to do each floor? If you are a construction manager, you want to finish every slab, every floor in how many days? 10 days, 15 days max. During, but they will not do. Theoretically, it is being done at the site. But then the finishing guy is already there. He will say, don't pour water, how will I finish? Right? So these are issues that you have to be careful about. There are multiple people involved in the life of the concrete. Ideally, somebody should take care of it until 28 days. But you go to site, no, it's not happening. It will not happen. Okay. Ideally, they want to lift and place it in 3 days. The finishing guy is there already inside. They want to start finishing so that every floor they will finish in 2 weeks max. 2 weeks is already late. Some construction manager is shouting at them why it's taking 2 weeks. So they have to finish everything. So this is the dynamics that you have to get used to. When we are students, everything is 28 days strength. But it's a different story when you go to the site. Okay. Any other questions? Any other doubts? Yeah. Yeah. Yes. Yeah. Very difficult. Very difficult. So as if somebody comes to me, I will say there should be at least one person paid to do only curing. Right now, who does curing? Somebody around there. If somebody goes, they'll say, go pour water. There should be somebody for curing. So this is something that we learned long back. And in your bill of quantities, there should be what payment for curing. Never I have seen it. Has anybody seen it? Never. You want it for free. Right? We want curing for free or by magic. Harry Potter will come and say water. Will not happen. We don't want to pay for it. Somehow it should get cured. So we should start. So ideally, for your vertical elements, if it's a column, we wrap with gunny bags, but the gunny bag will be dry. That is even worse. You're putting it through wetting, drying cycles very early in its life. The poor concrete will crack. Yeah. So somebody should keep on wetting. I know it's difficult. It's easy for me to tell, but we have to learn to do it. Otherwise, you will have trouble. You will have trouble. The cover will be of bad quality. And I think Professor Pillai, if he is not talked to you, he will tell you cover is very important for durability. So that is something very, very important. And also related to it is plastering. Why do we plaster? To cover our mistakes. Somebody yesterday or day before told me they're protecting the steel. I said, what are you doing? You cannot protecting the steel. You're making good concrete. You're hacking it. That means you're damaging it intentionally with all the, you think of your whoever, your boss or your wife, and come hack the concrete to hell, and then you plaster. You make good concrete, you damage it, and then you plaster. It's not helping concrete at all. Concrete plastering of concrete is only for covering up our mistakes. So I'll tell you a true story. I like telling stories. Our campus, in 2008, we said no more plastering of ceiling. Wall sometimes you have to plaster because it's so uneven, it looks ugly. So ceiling, we said we will not plaster. So we said okay. Engineers were told, contractor was told, we will not do plastering anymore. Then we found out that it was getting done. Then they will say, sir, very severe damage we had to get. So next set of contracts, we removed it from bill of quantities. They cannot operate. So what do you think happened? Huh? Putty is fine, cement putty is fine, gypsum putty is also fine. What else could have happened? No, contractor offered to do it for free. Huh? You understand? No, contractor said, sir, it's not bill of quantities, I'll do it for free. So her engineer is very happy. He's getting something free. Done, no? So these are the things which happen. These are all real stories. Our campus. So we have to be very careful of what we do. These are small things which matter a lot. When we talk about sustainability, imagine the amount of cement mortar that we are wasting on plastic. What are we talking about sustainability? So these are the things which matter. Why can't we make concrete well and leave it like? Yeah. 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 You can get it if your plywood is good, and if you just do putty, like somebody said, you can do gypsum putty, you can do white cement putty. It's very, yeah. Many of our campus buildings, a lot of them don't have plastering at all in the ceiling. Yeah. We can do it. It's possible. But the main thing is the contractor should know that he is not going to plaster. You will see just the change. If the contractor is aware that they are not going to get plaster, then it will be a different story. Yeah. Yes, sir. Yes, in the joints. Yeah, yeah, yeah. Right. Yeah, what is not shrinking? What is it that you're using? So what is not shrinking? The grout is not shrinking, but the concrete doesn't know. You didn't tell the concrete that it should not shrink. No, the poor thing will continue to shrink. So I have a joint. I have another precast element, and here you put the grout. Okay, then grout is non-shrink, but this thing is going to shrink. So this will open. So what will happen? It will crack. Yeah. 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 Go and see it after 1 year. So how to mitigate? Do the jointing late. Your wet joint should be done not in the beginning, but after a lot of time. So best thing is to get an idea of how this concrete is going to shrink. See, concrete shrinks and then afterwards it stabilizes. After that, you get very little shrinkage. So let the joint open, and then you do your ground. Then you do your ceiling. Yeah? Not at 3 days, not at 7 days. Then for sure it has to open. No, how can concrete not shrink? It will shrink. Yeah? So this understanding is needed. Don't finish your joints very early. Do your joints last. Then that will work. So that is the way around. Yeah, does it solve or cause more problems? More problems. Yeah. I know, I know, I know. No, there is no such thing as expansive grout, and it's also very risky. See, there are expansive cements, but that is during hydration. So it's very risky. If you don't control it, then that joint is trying to push the other things also. So you have to be very careful with expansive. In India, we do not use expansive cement. In UK, US, it's very common. They use type K. In India, we've been very hesitant because this cement can expand and cause a lot of compression forces. So you don't want something that is risky. In repair, they use it sometimes, but not in construction. Grouts also, they might be, but generally it is called non-shrink, which compensates for shrinkage rather than expand. Best is to use a sealant, like a flexible sealant, polysulfide, silicone, PU, polyurethane. Now I think polyurethane is the best in the market. So use a polyurethane. If the joint is very wide, you put a backer rod and then you finish. Yeah, but cement mortar alone will not solve the problem. That will not shrink, but it will not prevent your concrete from shrinking. Yeah, question? Yeah, tell. Yeah, yeah. So your grout should have the mechanical strength and the durability. Yeah. So when you are having column on column and you are leaving a gap for grouting, the grout should be at least as strong and durable as the rest of the elements. At least. That is the only way. It cannot be a weak grout, or you cannot leave it open, then there will be problem. Okay, but this is a very good point. It's very, very important to do it. And also how to make sure that the grout is fully filled up. That is why the gap is given. Because if there's no gap, you don't know how, if the grout has gone in or not. So intentionally you leave a gap, and then you know that you can fill it in. Yeah, so it's very, very important. Okay, all right. So I'll quickly go through. I think I have only 10 minutes. I'll just, these slides are anyway with you. I'll just go through some things. See, self-compacting concrete is a good thing to do. If you have prefabrication, if you have even regular concrete, because it takes away the person factor, the laborer factor, the worker factor, and you get some hold on quality. So I'll tell you how these tests are done. Let me, you can ask me questions meanwhile, while I put the USB drive in. Yeah. Oh, you had slump flow, you did? Okay. Then tell me about slump flow. If you know about it, you tell me. How is the slump flow test done? Quickly. Yeah. Justin says all of you know about this test. So you must tell me instead of me telling you. Huh? What is 700 mm? Yeah. So how do we do the test? Quickly. Okay. So this is how we do the slump test. I don't know what Justin showed you, but you take the regular slump Abrams cone, put it on a plate. You have to mark first 50 centimeters, then you mark your target diameter. Generally, if it's a column, it need not be very high. The slump can be even 600, it will still work. If it's a slab, maybe you need 700. Okay, so we don't have to go overboard. So you fill it, lift it up. Two things have to be measured: the time taken for 50 centimeters diameter to be reached, and the final spread. Okay, so what's been pointed out is the 50 centimeter diameter, and so somebody with a stopwatch is looking at it. So this is very good for precast because you don't have to worry about exactly the vibration and all that stuff. It works very, very nicely. Then the other test which Justin showed you is, so the J ring is the same as the slump flow, but we do with a ring of reinforcement to see if the concrete gets blocked by the reinforcement. You can take a standard reinforcement spacing, or what is the worst case in your element. Okay, so we do it and we see. Now we compare the slump flow test diameter with this, and if it's very different, more than, what did you tell them, 50 mm difference, then we reject. That means it's blocking. Okay, so these are tests that unfortunately there is no easy single test to do. So we have to do this, and each of this has a purpose. Okay, then somebody mentioned slump flow. So V funnel test is good for pumping. In prefabrication may not be very important that way, but for segregation it's very important. So we do this test 2 times. Okay, we fill this funnel, measure the time taken for concrete to go through, then do it again, but this time you let it sit there for 5 minutes. So what happens in this 5 minutes, if it's a bad concrete, starts to settle down and it will block the concrete from coming out. Okay, so comparing the 2 times, it should not be more than about 3 seconds, then you know that this concrete is not segregated. Okay, so these are tests that we generally do. So self-compacting concrete is a good concrete, but you have to do some things like this in order to see how beneficial it is. Okay, now let me show you one of my first experiences with prefabrication and self-compacting concrete. This is all real stories. This is in a factory. If anybody has gone to a prefabrication plant, you will see a lot of metal molds. Like somebody said, Umesh, yeah? What is your name? I forgot your name. Soham said that sometimes the mold lasts a lot of time. So this type of mold, yes, it will last for 100, 200 times. When it's in a factory, you're doing it very, very carefully, then it will last for a long time. But in the site, generally not that much. So here what they are doing is, they are doing like a bench, and like benches that you see in our campus, you will see a lot of concrete benches around. So the inspiration is from here. So this is a major company in Spain, Escofet, and I was working there, so I got this opportunity. And you can see the operations involved for making a vibrated prefabricated element. They have to put the mold on top of this metal frame, lift it and put it on a vibrating table. So this whole thing vibrates, and the concrete has to go through it and fill in. So it's a lot of vibration, and generally the worker is standing on the vibrating table. So the worker is undergoing the same vibration as concrete, but hundreds of times in his life. So they get a lot of health problems. They get migraines, they get something called white fingers. Blood stops flowing into the fingers. Okay, blood doesn't flow into the fingers because they're always vibrating. So this is a huge problem. So there is a huge motivation in construction to go away from vibrated concrete, because this vibration is harmful for you. Concrete gets only vibrated once in its life, but the worker gets a lot of time. So it's a very difficult thing, and lot of noise also. You will see that all of them have earmuffs. So this is 2004. 2004. So we went to this factory and said, can you give us an opportunity to try out self-compacting concrete? They said, okay, you do one with regular vibrated and one with self-compacting. Let our workers also see the difference. So this, what you are seeing, is vibrated concrete. Concrete is put there, then you will see, I'm cutting out the sound, but the vibration has started now. You see that it's flattening out, and the concrete is going through the side, and you will see the vibration of the reinforcement bar on this side. Then that is not enough sometimes. So what will happen is, there will be somebody who will climb on top with a needle vibrator, and again he is doing the same thing. He is pushing the concrete through. Okay, so this is somebody who's standing on the vibrating table with the needle vibrator, pushing the concrete through. So you can imagine how much effort and strain these people have. So in prefabrication, there is a lot of noise, vibration, strain that these workers have to go through. Okay, then it's finished up. Now I'll show you same element with self-compacting concrete. Same day, 20 years back. Okay, so this part is now going to be done without any vibration with self-compacting concrete. Lot of workers were just curious. They wanted to see this amazing concrete which does not need any vibration. Okay, to show you the fact. And this guy, I'll tell you about this guy. This guy was in charge of the plant. Afterwards, he said, "So this is amazing. We have to go with this concrete." I met them. I went again and visited in 2008. 80% of their concrete was all self-compacting. And this guy came and he remembered that we had helped them change this concrete. And there was no noise. The factory was quiet. Factory was quiet, fewer workers, and things were really going well. See, it's all done. In 3 minutes, the concrete is all poured, whereas the other one, lot of effort and doing it. And the factory themselves changed. They believed that this is the way to go. And in 4 years, their transition went from zero SCC to 80% of their product being SCC. Okay. So that's the story, which really tells that there is an advantage to doing this thing. Okay. So self-compacting concrete I've covered. Any questions on SCC? Any questions on self-compacting concrete? You can use it anywhere, but I think prefabrication, lot of advantages. And if we can use it, it's going to be very useful. Okay, I have 6 minutes. What do you want me to talk about? Okay, thank you. Okay, so, well, AAC blocks, again, precast, we use them a lot. We plastering is very, very important. You lose because of porosity. So textile reinforced concrete, I'll just show you because Professor Amlan reminded, this is a new type of concrete. We are doing it and people are using it on housing also. We just came back from Rajapalayam where somebody is building houses with textile reinforced concrete. So basically it is concrete with this type of behavior. Concrete where you have a strain hardening type of behavior. So cracks are happening, but there are multiple cracks. Okay, there are multiple cracks like this, not one single crack in tension. So it's like a multiple cracking, and this gives this type of behavior. And how do you do it? You reinforce it with glass. So what could be advantages and disadvantage by reinforcing by glass instead of metal? One is no corrosion. Now, have you heard of ferrocement? Yeah, some of you might have heard of ferrocement. This was very popular in the 60s and 70s, where we used thin elements to do drop panels. We used to do shelves, all these things with metal mesh. The problem was corrosion. So basically, it is the same thing that we are using glass. So glass should not corrode, but it also gets attacked by alkalis. So it's slightly different story is there, but generally it will not be corroded. So there have been applications in prefabricated elements. So these are on the left is Germany, in the right is India. So there are applications also. So you can make very nice elements. This prefabricated again is in India. This is in Germany. Then this is a bridge that was done in Germany. Now I'll tell you about our project. We did one project called Clean Water, where we did a sewage treatment plant with prefabricated elements. Okay, the structure is like this, different tanks. This could be also for water, could be for sewage and so on. So we did finite element analysis. We use glass fiber, glass textile, and this is the behavior that we get. And we made these ring elements like this. So we made a mold, and then the textile is put around, and then we fabricate the tanks to the height that we require by putting one ring on top of the other. Okay. Then for transportation, instead of making the rings all of the same size, we made them different sizes. So it can all go inside one another. Okay. Well, Sachin was the one who got this project and did most of the work. So afterwards you ask him all the questions. So these rings go one inside the other. For transportation, it becomes very, very easy. And we tested it also by filling it with water to see if this can hold water or not. And this is the sewage treatment plant layout. So a slab is placed, and then these rings are put and connected like this. So the sewage water goes in there, goes through filtration, sedimentation, and the anaerobic treatment and comes out. So textile reinforcement is also a good way to do thin elements. And there are people now doing it for housing also, where they're using it as loss formwork or panels. Safeguard. Yeah. So Sifcon has lot of fibers. So it will have lot of steel fibers. And what you do is you take the mold, first you fill it with steel fibers. Then you pour the slurry inside to fill it up. So this they use a lot in bank vaults, like to protect the bank, to make a bunker. That is, so recently we might have heard that in the war, US used these bunker busting bombs. And one of the reasons was that Iran, it has been claimed that Iran has something like Sifcon in its bunkers. So this came out long back, that UHPC or Sifcon was used by Iran and some other countries to make their bunkers. So they become blast resistant, very heavy reinforcement. So you need a lot of energy to break through. So that is one reason why they talk about these bunker busting bombs that were used. Okay. So what I'm flashing here is again prefabrication, but for tunnel line, where again we are thinking that fiber reinforced concrete can be used, but now regularly reinforced concrete is used. For those of you who are not familiar with precast tunnel lining, so all metro tunnel linings are done this way. Okay, so you have the tunnel boring machine that is going into the rock. As it is going, it is building the tunnel ring by ring. Okay, so this is an operation where excavation and construction are finished together. As the tunnel boring machine is pushing, it is pushing against the already constructed rings. So it's reacting a lot. So the tunnel segments have to undergo very heavy compression along the axis of the tunnel. Then afterwards, the soil compresses them. So it changes during its life. So a lot of times there, and one advantage of fibers is that this could on it. We have some leads where or additionally put reinforcement put fibers. So this is the sequence in case you have not seen this procedure. So this is how the segment is made. In any of the metros, underground metros in India, so the segment is made like this, operating table. Then afterward it is steam cured. In very early age, this one will have a, okay, 6 to 8 hours it's lifted. Here it has 1 day. Here this is 1 week. Okay, and some cracking. So this also has to be checked in the design. Needed for 1 ring. Okay, so this, the whole tunnel is, in this case it was 1.8, in 10.2 meters, the segments. Then afterwards the TBM now pushes, and for pushing it has to react against something. So it's already been built. So it goes for say 2 meters, the jacks are withdrawn. These are the jacks are withdrawn. Then there is space for 1 ring, that ring is put. Then it moves ring by ring, and that is how your metro tunnels are constructed. Lot of prefabrication. This is the fastest way to do tunneling. So in metro tunneling anywhere in the world, now mostly they will be doing like this. Railway tunnels have started. In our Rishikesh to Karnaprayag section, lot of main sections are being done like this. The whole train, the big train is going to go in tunnels like this. Okay, in tunnels made with segments like this. Reinforced concrete and also fiber reinforced concrete in the future. Other countries are doing it and India will get there. So this is the robot arm that is placing the segment as the TBM is moving. Okay, we've done some tests. This is in structures lab. Probably when Professor Amlan was HOL. So we have done some tests to validate the design. These are recent work where we've looked at the Patna metro to see if we can suggest as alternatives fiber reinforced concrete. So this is where the jacks come. Jacks apply a lot of force. So the jack applies force here, and we have to see whether it will crack or not. So these are finite element analysis to see what are the high stress areas. Then we have to check quality as well. So this is a proposal that was given for quality. We cut and see if the reinforcement and the fibers are uniformly distributed or not, and then the strength.